Good afternoon, Dr. Zhang. I am Sudarshan Podal, and today I'm going to conduct an experiment to calculate the rate of water removed or restored at a bucket. So we're gonna use the law of conservation of mass for this experiment, and for the experimental setup I have two buckets and one bucket to collect the water, as you can see right here. Let me show you. Wait a minute. Okay, it's right here. I have a can of Coke without the Coke, and I have one small bucket with a hole at the bottom. I have hole over here too, and I already knew the diameter of this. I can find the diameter, which is approximately 0.6 centimeters. And I know the diameter of this one too, 0.8 centimeters. I am gonna pour the liquid from the top on this vessel, and then the liquid is gonna flow from here, and then it'll flow from here, from this outlet number 2. So we are gonna find out the velocity of the flow from this outlet V1, and then find out the V2, and then we can calculate the mass of the water that is restored or leaving the bucket, in which this water to a height which I know. Okay, and I'm gonna keep this and this. As you can see, the water goes over here and then falls from the bottom. So this is a unsteady process, as the mass changes over the time, but it's a controlled volume process because we have our volume constant. We know all our calculation, and let's go to the calculation part. So I have the experimental setup right here. I have the top vessel, bottom vessel, and the water collector over here. So for the volume of the top vessel, I have height 1 equal to 13 centimeter, which is 0.13 meters, and which gives the velocity of the inlet as 1.59 meter per seconds, and the inlet velocity is 1.59 meter per seconds. I have the diameter 1, I have the diameter 2, 0.006. I have the V2 outlet, which can be found by using the continuity principle, which is V1 over V2 equals A2 over A1. A2 is directly proportional to diameter. That's why V2 equals 1.59 times D1 square over D2, which gives velocity of the outlet as 2.83 meter per second. And to find out the volume of water that's restored or leaving, which in case is inlet minus outlet, equals to 0, and through the calculation we can find out it's gonna be 9.42 times 10 to the power negative 5 kg per second, which is really small because our diameters is very small. It's in centimeters, and there are some errors in the experiment too because of the fault, because the liquid was leaking, as you can see from here, and the signs will be negative because the water is leaving the system.